Here in this section, we have first order linear equations. First order linear differential equation is one that can be written in the form dy over dx plus p of x times y equal to qx. P and q are continuous functions of x, and this equation 1 is the linear equation's standard form. Since the exponential growth decay equation dy over dx equal to k times y can be put in the standard form, which is dy over dx minus k times y equal to 0. So it is a linear equation with px equal to negative k and qx is equal to 0. The equation 1 is linear in y. So here is how we can solve. So to solve the linear equation y prime plus p of x times y equal to qx, multiply both sides by the integrating factor, which is v of x equal to e power is integral px times dx, and then integrate both sides. Example, solve the differential equation x minus 2 times dy over dx plus y equal to 3 times e power is x, and x is greater than 0. So to solve the linear equation dy over dx plus px times y equal to qx, we have to multiply both sides of the equation by the integrating factor e power integral px dx, and then integrate both sides of the equation. So first we should have what is given in standard form. So what we're gonna do, we have to divide by x minus 2. So here we have dy over dx plus 1 over x minus 2 times y equal to, on the other side we have 3 over x minus 2 times e power x. So what we have here on this part, for px is equal to 1 over x minus 2, so it's this part, the coefficient of y. Now find the integrating factor e power integral px dx. Use the constant of integration, c equal to 0, so y is as simple as possible. So here what we have, e to the power integral px dx, that is equal to e power integral. For px we have 1 over x minus 2 times dx. So this is equal to e. So integrate what we have here for px dx, that is natural log x minus 2. So this part cancels, and the answer here is equal to x minus 2. Now multiply the equation in standard form by the integrating factor x minus 2. Here we have standard form dy over dx plus 1 over x minus 2 times y equal to 3 over x minus 2 times e power x. So multiply this one by x minus 2. So here we have x minus 2 times dy over dx plus 1 over x minus 2 y is equal to x minus 2 times 3 over x minus 2 times e power x. So simplify here, we're going to have x minus 2 times dy over dx plus y. Here this part cancels after multiplying. So that's how we have y here, and other side x minus 2 divided by x minus 2, so we're going to have 3 e power x, so 3 times e power x. So the left side of this equation is the derivative of the product x minus 2 times y. This part is the derivative of x minus 2 times y. Based on that, what we have here on this part, d over dx, x minus 2 times y is equal to what we have here on the right side, 3 times e power x. Now integrate both sides of the equation. We have x minus 2 times y equal to 3 times integral e power x times dx. And then simplify, so x minus 2 times y is equal to 3 times e power x plus constant c. And finally, divide both sides of the equation by x minus 2. So what we have here, y equal to 1 over x minus 2 times 3 times e power x plus c. So this is our solution. So the solution of x minus 2 times dy over dx plus y equal to 3 times e power x is y equal to 1 over x minus 2 times 3 times e power x plus c. So this is our answer for this part. Solve the differential equation x minus 1 times y prime plus 4y equal to 2 sine x divided by x minus 1 cube. X is greater than 1. First, put the equation into standard form, which is y prime plus px times y equal to qx. So we have to divide both sides by x minus 1. So after dividing by x minus 1, we're going to have y prime plus 4 over x minus 1 times y equal to, now on the right side, we have 2 sine x divided by x minus 1. Here, power 3, because of dividing by x minus 1, we're going to have power 4. So x minus 1 to the 4th power in denominator. And here in this case, the coefficient of y is 4 over x minus 1, and that is px. Note that here in this case that this division is possible because what is given here, x is greater than 1. So we cannot have, for example, 1 here for x. 1 minus 1, we're going to have 0, and 4 over 0, that will be undefined. So here x is greater than 1. To solve the linear equation, we have to multiply both sides by the integrating factor, which is px equal to e power integral px dx, and in this case, px is 4 over x minus 1. Find Vx, use a constant of integration, c equal to 0, so Vx is as simple as possible. So what we have here for Vx, that is equal to e power integral, px is 4 over x minus 1 times dx, so this is equal to e, and integrate, so we're going to have 4 times natural log x minus 1, so that is equal to e power natural log x minus 1 to the 4th power. So move this here onto this part. And then this part cancels. The answer is x minus 1 to the 4th power. So this is our Vx. So multiply both sides by Vx. We're going to have x minus 1 to the 4th power times y prime plus 4 divided by x minus 1 times y equal to x minus 1 to the 4th power times what we have on the right side, so that is 2 sine x divided by x minus 1 to the 4th power. Now simplify, so here we have x minus 1 to the 4th power times y prime plus 4 times x minus 1 cubed times y equal to, on the right side we have 2 sine x. So the form of the equation becomes d over dx, Vx times y equal to Vx qx. So the left side is d over dx, x minus 1 to the 4th power times y. So what we have here is d over dx, x minus 1 to the 4th power times y equal to what we have here on the right side is 2 sine x. Now integrate, we have x minus 1 to the 4th power times y is equal to c minus 2 cosine x. And c is constant of integration. Finally, divide both sides by x minus 1 to the 4th power. So we're going to have y equal to c minus 2 cosine x divided by x minus 1 to the 4th power. And this is our solution for this part. Solve the initial value problem. Theta times dy over d theta plus y equal to -2 sine theta. Theta is greater than 0, and y of pi over 2, that is equal to 1. First writing in standard form, which is y prime plus p theta times y equal to q theta. So divide both sides of the equation by theta. We're going to have dy over d theta plus y over theta equal to, on right side we have -2 sine theta divided by theta. Based on what we have here, coefficient of y here is 1 over theta, so that is p theta. So integral p theta d theta is equal to integral p theta is 1 over theta times d theta, and that is equal to, so here integrate, this is equal to natural log theta plus constant, which is c. So based on what we have here, v of theta is equal to e power integral p theta times d theta, and this is equal to e. For integral p theta d theta, we have natural log theta, and then this part cancels, and what we have for v theta is equal to theta. Now multiply both sides of the equation by v of theta. So this is our equation. Multiply both sides by theta, we're gonna have theta times dy over d theta plus y equal to -2 times sine theta. So what we have here on left side, d over d theta of y theta, that is equal to -2 sine theta. So this was using the product rule, and then integrate both sides of the equation. So here we have integral d over d theta y theta times d theta equal to the other side, integral -2 sine theta d theta. And then simplify, we're going to have y theta equal to 2 cosine theta plus c. Now solve the resulting equation for c using the initial value condition. And so what we have for y of pi over 2, that was equal to 1. This is what was given. So substitute y equal to 1 and theta equal to pi over 2. So what we had from last step, y theta equal to 2 cosine theta plus c. Now for y we have 1, and for theta we have pi over 2. So here on this part we have 1 times pi over 2 equal to 2 cosine pi over 2 plus c. And then simplify. So here we have pi over 2 equal to 2 times cosine pi over 2 is 0, then plus c. So c is pi over 2. And finally substitute c equal to pi over 2 into the equation and solve for y. So this is our equation, and then instead of c, now here we have pi over 2. Next step, divide both sides of the equation by theta. So we're going to have y equal to pi over 2 theta plus 2 cosine theta divided by theta. So this is our final solution. Solve the initial value problem. dy over dx plus 3 times x times y equal to 10 times x. Y0 is equal to 5. So what is given on this part, this is in standard form. So this is in the form of y prime plus px times y equal to qx. The coefficient of y here in this case is 3x, and that is px. So based on that, we can find v of x. So here, what we have for vx, that is equal to e power integral px dx. So substitute 3x for px. We have vx equal to e power integral 3x dx. integrate. So this is equal to e power 3x squared divided by 2. Now multiply both sides of the linear equation by the integrating factor, which is vx. So here multiplied by e power 3x squared divided by 2. And that same thing here on right side. So what we have here on this part, d over dx, e power 3x squared divided by 2 times y is equal to e power 3x squared divided by 2 times 10x. So what we have on left side, that is d over dx times v times y. Now integrate both sides and simplify. So here we have e power 3x squared divided by 2 times y equal to, on the right side we have 10 over 3 times e power 3x squared divided by 2 plus constant c. Now solve for y. So y is equal to 10 over 3 plus c over e power 3x squared divided by 2, but I'm going to move that to numerator. So we're going to have c times e power negative 3x squared divided by 2. So what we did here on this part, we divide both sides by e power 3x squared divided by 2. Next, we'll use the initial condition to solve for c. So solve for c using what we have for x and y. So what was given for y, we have 5 and x is 0. So 5 equal to 10 over 3 plus c times e power negative 3 times 0 squared divided by 2. So here we have e power is 0, that is equal to 1 on this part. So we have 5 equal to 10 over 3 plus c times 1. Simplify, solving for c, c is equal to 5 over 3. Finally, substitute 5 over 3 for c. Here is our solution. So we have y equal to 10 over 3 plus 5 over 3 times e power is negative 3x squared divided by 2.